Welcome to this video where today we'll talk about finding units and what correct units should be. Here's the basic procedure on solving for units that you can follow anytime you are confronted with a problem like this. Step 1 is to solve for the unit that you are looking for. Solve the equation for whatever variable it is. 2, plug in units, and then 3, simplify. And if you do these 3 steps, you will get your answer. Here's how you do it. In this case, I have a tank oriented on the X and Y axes with the Z pointing straight up. I'm going to do some pressure distribution calculations on this problem in this next video. But for right now, we'll just focus on units. Let's say, hypothetically, that I have the pressure in the tank equals a constant times gamma, or the density there inside, to a unitless constant. We know the dimensions of pressure and density, and we know that this has no units. So we're concerned with finding what units are for our constant. And since we have a generic power, this can be very complicated in finding generic units, but it's very helpful. This video is orientated towards thermodynamic applications, as you'll be doing a lot of this kind of thing in thermodynamics. So, where do we begin? Well, first I want to solve for C. I'm going to say, move C to the other side and say 1 over C times pressure equals equals rho to the gamma power. And then I'll move pressure to the other side and say 1 over C equals rho to the gamma power divided by pressure. Reciprocate both sides, and I have C equals pressure over gamma rho to the gamma power. That's 3 times in a row. 3 times in a row. Well, pun intended there. So, all I have to do now is fill in the dimensions that I know and simplify them to find C. In this case, it's going to be C equals, and I know my base dimensions for pressure is mass divided by length times time squared. So I'm going to say mass is kilograms divided by length times time squared, which is seconds squared. Then I will divide and say my rho is going to be a mass divided by a volume. So a mass divided by a volume. Volume is length cubed, so my length cubed in this case will be a meters cubed. And this will be to the power of gamma. So instead of writing symbols here, I've just added what the units are instead. Now I simplify and solve. So coming up here, I'm going to have C equals, and I'm going to reciprocate our denominator and multiply, because to divide by fractions to multiply by its reciprocal. So I will say kilograms divided by length times seconds squared times meters cubed per kilogram, and all of this will be to the gamma power. Now I will simplify further and say kilograms times meters times seconds squared times meters cubed to the gamma divided by kilograms to the gamma. So what have I got here? I can cross cancel both of these to come up with one fraction, and that's very helpful when you're trying to simplify. In this case, this will give me meters to the power of 3 gamma minus 1, because I have meters to the 3 gamma, and then to cross cancel I subtract 1, and then I multiply that by kilograms to the 1 minus gamma. My gamma is in my denominator, and this is kilograms to the first power. So this is technically kilograms times 1 minus negative gamma since that's in the denominator. And then I divide both of this. I've canceled out meters and kilograms in the denominator, which leaves me with seconds squared. And that is the unit for C in any generic pressure equation. And my hand must have erased my row here. So this is very beneficial. We've just done a very generic or parametric equation, and this is applicable to anything now because we can put any value of gamma in there for any application tank. Hope this is helpful, and we'll be doing some further calculation on pressure distribution in the tank in this video here. If you have any questions, you can contact me at Joko Engineeringhelp at gmail.com. Visit our Facebook page here, and you can find a directory of all my tutorials here. Thank you for watching, and I'll catch you next time.